Hi. So how many of you are comfortable with functional programming concepts or functional programming languages? Cool. So how many of you started out with like Java or C# with some OOP languages out of those? Yeah, similar people. So hopefully in this talk, we're going to go on a journey, like you can see for the footsteps, that we're going to go through some of the confusing parts and some of the parts where people are more likely to have questions about functional programming when they first started hearing about it or studying about it. Cool. So just a little bit introduction. I am a software developer. I am learning Haskell, and I'm currently a part-time student as well. And when I'm not doing programming things, I am one of the co-organizers for our local Utah Haskell meetup. And I practice Aikido, and then I talk in conferences. So one of the topics that I talk the most about is how to make front-end development more functional. And during that, I realized that people still have some questions about functional programming in general after they learned about some of the concepts. And just like some of you, I started out with learning about Java and then C# back in school, and then doing some C++, and then I got a job using Java as well. So I started out with OOP languages. And I started hearing about functional programming languages about middle of last year, and I started learning more about it. And at first, I was like, this is awesome, and now I can't change my data anymore, and I won't get into those nasty situations where the states of my app is all confusing and all that. But after a while, I realized that I'm still kind of not quite getting functional programming. Like, why do I actually need it? So I also asked on Twitter for some of the things that people are getting confused the most when they first started learning about it. And these are some of the most common questions. And I think for the last few talks, we all heard about Elm and how to think functionally. And they all talked about immutable data structures. And surprisingly, that's also the part where people have questions about. It's more about memory efficiency and how to actually do anything if things are actually not changeable. And the second part that people are most confused about is object-oriented programming versus functional programming, and why do they have to choose either or why is functional programming better? And the third part is languages. Basically, which languages should they first start learning when they start learning about functional programming, and so on. So I'm just going to go through them one by one. So now I want you to imagine you sitting in your office or at home doing your Java apps or whatever, and then you heard about functional programming. You're like, okay, this is pretty cool. I'm going to do some search about it. And one of the reasons that we don't like mutable stuff is, of course, because he says so. One does not simply mutate a data structure. But more importantly, when we first encounter functional programming concepts, one of the major things is immutable objects. And then we start Googling about it. And basically, we learned how once an object is established, we cannot change that existing object. And every single change on that object will create a new object. So then we're like, okay, this is pretty cool. I won't be producing all that bugs when I try to change my object anymore because that object can be changed. But is it really efficient when we create a new object every single time when we want to change something? That's actually not the case. We're not actually really creating a new object or rather, a new object is not really the same as a new copy of the entire object of the old one. So, so a lot of these functional programming languages actually have built-in immutable data, and they actually use this concept of memory sharing, which looks pretty familiar from the React talk about how you should use the ship component update. So this is a fairly similar graph. So on the left-hand side, we have the old data, XS, which has some parent node D and then has some child nodes, right? And then we want to add a new child node onto the bottom row F. So then we're not actually copying every single data inside of the XS into YS. We're simply copying only the parent node of the changed child node. So, so in this case, we have the E node, and then we're copying over the parent F to F prime, and then similarly, we have the G, and then we have the D, and then that's the root node. And then everything else we're actually sharing with the old data. And some of you may know from Java or something that memory sharing is not safe. And that is true in immutable data structure languages. Because if you can't change data, then the things you're sharing may also get changed, so then the things that you thought you knew may not be that thing anymore. But memory sharing is completely safe in this case because the old data can't be changed anyway. Okay, so now you say, okay, memory efficiency won't be a problem, but why should I really care about this kind of things? So here are some of the benefits of why this may be more important than just memory efficiency. So the first one is no more locking on multi-thread operations. So because the data won't be changed, we won't need to lock every single thread to prevent the changes on the old data because they won't be changed anyway. And so now we have copying, right? When we copy an object, we're really just creating a new reference of that object. And so in this case, the copying will be in constant time rather than n. And sometimes we need to do a value comparison, and that is actually just a reference comparison. So that's also faster. And then we, of course, get data consistency, which is always a good thing. So there's no surprises of which data we're touching and then which data we're changing, and that may impact other data in somewhere else. So we don't need to worry about that anymore. Which leads to the final point is that immutable data gives you a piece of, or it provides a peace of mind on you and on other developers. Okay, in this case, so on the top part, we have the checking balance, and you're checking the checking balance, and you don't want your checking balance to do minus 1,000 every time you check it, right? So don't change your data. No. So on the bottom part, we have this list. We have this AL list that has tuples in them. So 1, 1, 2, 2, 3, 3, and so on. And now we want to insert another tuple, 100, into this AL list. So on the bottom, we can see the red part where it actually produces the new list, which has the new data in them. But if we check the AL, it's not actually being changed. So just in case someone else is also using the AL list, then that AL won't be affected just because you're doing the insert on this method or something. Okay, now let's jump to the second part, which is how do you actually do anything if you can't change any data? Okay, so we have this JavaScript function, factorial. Basically, we do a for loop, and then we change the result every single time, and then we times the I until n, and so on. And then we return the result. But in this method, we're changing the result every single time. So how do you actually not change anything? That's where recursion comes in. So on the top half, we have this Haskell program where we have the factorial. And since Haskell has the pattern matching, we can pattern matching on when the input is 0, we just return 1. And if and then if it's anything else, we return the recurse factorial function on n minus 1. And you don't really need Haskell to do this. You can do this in JavaScript or Java or anything, which is the same concept that you just check if n is equal to 0 and then return 1. That's on the bottom part. And then for anything else, you just simply return the n times the factorial of itself with n minus 1 until you hit 0 again. Okay, so the second part is OOP versus functional programming, right? So in object-oriented programming, we tend to keep data and behavior together in objects, and that's why it's called object-oriented. But in functional programming, we tend to keep data and behavior separate, and then we tend to do more functions rather than classes, hence the name. So in order to know why functional programming is better, I think we need to know a few more concepts, which is pure functions and composable functions. So from the previous talk, we all know pure functions or stateless functions is actually just means same inputs, same outputs. And actually, we're already doing this in math that we used to do. We have the, so right here we have absolute value of -1, and then we get 1 out every single time. We're not going to get like 5 out. Same thing with the square. We have 5 square is 25. That's consistent every single time. There's no changes in the result. Even though you can change anything else, this result will always be the same as long as the input is 5, right? So I think pure functions makes it hard to actually mix data and logic. So for the increment function, we give it n, and then we return n plus 1, and we're not changing the given n. We're simply returning n plus 1 every single time. So if you give it the same number, you will definitely have the same result. Same with the update status. So we give it a person object, and then we're calling this other function, pure check, and then passing the same parameter, and then we're simply returning a Boolean of whether this person graduated college or not. And then we're returning true or false, and then based on this function's result, we're returning a new object that assign this brand new object, and then copy everything over from person except changing the graduated status from false to true, and so on. And so in this case, we're not changing the given person object. We're simply returning a new person object with the updated status. Okay, so that leads us to composable functions. And just like how we do it in math, we have g of f of x, which is just really passing in the result of f of x back to g, and then have some output. This actually is better if you do pure functions with it, just so you guarantee the result of every single function before passing them in. So you're actually guaranteed the result of your composed functions as well. And some functional programming languages have types, right? So types is actually just like you're saying this input or output type has to be an int or a string or so on. So let's say G function takes an integer and then returns a list of strings, and then F takes a a character and then returns an integer. So the only way this could work is we're putting the result of f of x back to g. So it's always given a character and then return a list of strings. This actually guarantees that you're getting the right value to your second function or your third function every single time. So you're not getting some random value of some random type that your second or third function are not checking. So in this case, we can't do f of g of x, because then we'll be given an integer and then produce a list of strings. And then we're trying to fit this list of strings to a character, which is not the right type. So for the simple math, I just want to emphasize on this pure function concept. So we may not notice that we're actually already doing pure functions because, so in this case, we're using JavaScript, and then JavaScript has a lot of built-in functions, and tons of them are actually pure functions, like in math. So we have the math.log10, and then if we give n of 0.01, we will always get -2 back. That's the case every single time. It doesn't care if you do some outside changes. And similarly, we pass in the -2 to math.absolute, we'll always get 2 back. So when we use these functions, we're actually using the good practice of stateless functions. So for this check condition one, we are passing the val, and we just have to make sure that we pass in a integer or double or some sort. So basically, all this does is we check if the value is equal to 15, and then we will return value times 2. If not, we'll just simply return the value back. So we're not changing the input. So underneath, I'm having this vals list of 1, 15, 15, and 20. And then we pass in this list into this filter, and returns the list.map. And in JavaScript, .map actually produces a new set as well. So we're not changing the vals. And then we're returning vals.map, and then pass in this check condition function, which is also pure. And then we're returning the new list. So that's just some of the ways that you can do to using these concepts without using any functional programming languages. Okay, so some of the benefits of using composable and pure functions. So since pure functions guarantee the result of every single function, if you compose them together, you will guarantee the results of your composed functions as well. And I think this makes everything easy to refactor. Since refactoring your app is always a pain, if you separate out each logic into one function, it's also easy to move things around. And of course, this gives you a better organized code base. Because when somebody new comes in, all they need to understand for this function is one logic. So you're not mixing all the states, basically. Okay, so what languages should I start with? And that's a very fair question, because there's Haskell, there's Clojure, there's Racket, there's Erlang, there's Cinderella, there's Pizza, and the last one, or the last two, are true functional programming languages. So there's so many functional programming languages, and that's why people always have problems to choose one or two. And I feel like it's fair to say that you should probably learn just a little bit of like Haskell, Clojure, and Racket and stuff, just so you get a feel of some of the pros and cons of each language. And then you can choose which language fits better for your code base. And here are some of the example ones. So for Haskell, it's a purely functional language, and it has types. And then it definitely promotes modular functions. And PureScript is actually a fairly new front-end language. So PureScript is written in Haskell. So it definitely has a Haskell syntax and all. And then it compiles to JavaScript, which is super easy to integrate with your current JavaScript apps. And then it has a fast growing community as well. So people are actually very engaged in making PureScript better and so on. And Clojure is another one. It uses, it's one of the JVM languages, which means it's really easy to integrate with your Java or Scala apps. It's not typed, but it does promote more modular functions. And ClojureScript, of course, is it's written in Clojure, and then it has a similar syntax. And it compiles to JavaScript, and it also has a very engaging community. So F# is actually gaining steams right now. So it's typed, and it's open source. And a lot of times, I've heard that people are actually slowly converting their C# projects to F#, which is a good thing. So some of you may have problems or using those programming languages because maybe your boss said, okay, we can try it, but what if you leave? Then I will have problem hiring somebody new to take over and to learn these languages. Actually, you probably won't have any problems hiring because there are always some people eager to use some functional programming languages for their work. And I've heard that, if you mention functional programming languages on your job listings, you will actually get people who are actually interested in those things, and they will more likely to produce good coding practices. So conclusion is, immutable data structures are efficient. It's actually more efficient than mutable data. And functional programming produces more reliable code, and it's not scary. Scary because you just need to know the basic concepts and then try some of the languages, and then just to see how you like it. So that's all. And so if you have any more questions, please feel free to talk to me afterwards or to tweet about it. Cool. Thank you.
Hello. What do you think? What do you think is the biggest barrier in doing the switch from OOP to FP?
Well, change is always hard, I think, for most of the people, and some of them think, oh, now I have to learn this new thing and change the way I think. Just like I mentioned, there are some of the confusions that people may still have about how efficient it is to actually use some of the functional programming languages, and why do I actually need to change it? So it's kind of like a pros and cons list, I guess, if you do it. Like pros is like, okay, I may have a better practice and then I may make the code better, but the cons is always, oh, now I have to spend time learning new things. So I think that's, I think it's definitely a switch of mindset into this new thing, but I think it's definitely worth it.
Okay, thank you for the talk.
Yeah.
I wanted to ask you about debugging.
Yes.
So in functional programming, if you start functional programming and you do more practical things than just using short functions,
sure.
You end up using some abstractions like streams or doing reactive. And yeah. From what I saw, it's much harder to debug such things because a regular debugger for procedural programming is not applicable anymore. So how do you handle debugging such things?
So I think somebody else also mentioned, so if you actually using the purely functional languages, it's hard to have runtime errors, but you might end up with lots of errors when you first try to compile the program, and a lot of them have very good compiler errors. So from there, you can actually check where it went wrong, and then once everything actually compiles, it's really hard to have any runtime unless it's like side effect things. So, but that is a very good question because I think in the real world apps, you definitely will have those runtime errors. So I'm not so sure. Yeah, we'll have to talk about it later and see.
After the years of development, why do you think that the application, which is written in functional style with functional programming language, will not result in the same mess as you can get with the OOP style?
Why does it not resolve?
Yeah.
I think, well, I don't have any. Well, I don't have any example of things not resolving. Do you have any, or?
I don't know. Maybe you know.
Oh, well, I was thinking that it actually does resolve a lot of the messes that, like Java or C# produces, just because it keeps the state very clean. So it's very hard to actually have a mess. But I mean, I think it does happen. I just never had it.
Thanks for the talk. I was just curious, what's your experience with handling side effects in the functional programming? Because sure, real-world apps needs databases and storage and so on.
Right.
What's your experience with that?
So, so I'm still learning Haskell, but so I know in Haskell there's an I/O type that that's specially reserved for handling side effects. So basically, it kind of forces you to know where you want to put your set, or where you have those things. So then it kind of lets you put everything inside of the I/O type. Then I think it's also a good way to let other developers know that that thing is a set effect. That's one way of doing it. So it's more clear communication overall. And then it keeps the pure functions separated from the side effect ones.
Hi. The creator of Scala is saying that the objective and functional programming are orthogonal, that you can use both of them. Mm-hmm. And also you are concentrating on pure functional languages, while most of the new languages have bigger or smaller support to functional programming. Mm-hmm. Scala is fully supporting it, Ruby is fully supporting it, the languages like Kotlin, Groovy and Java 8 have some support. Mm-hmm. I think the biggest concern for the most of the people is not how to switch to pure functional languages, mm-hmm. is how to use the functional concept in the projects which they are doing and in the tools they are using. And it's possible since last few years when all the languages are switching that. Yeah. Could you tell a bit about this kind of switching?
So I think, so you mentioned Scala, and Scala is definitely a great gateway from Java to a more functional or to a purely functional programming languages. And things like Scala definitely promotes these kind of concepts. But I know it's really easy to do object-oriented programming in these kind of languages because it can be both ways. So if you don't be careful about the functional programming concepts, you may end up writing your Scala app just like how you write your Java app. So yeah, but so some of the concepts that that I talk about here kind of, or hopefully it clears out some of the confusions that people may have. And I think a lot of times you just have to try it. And I think it's good to try some of the purely functional programming languages just so even though you may still not clear on some of the concepts, you can kind of see how using object-oriented concepts may actually prevent you from programming in the functional programming languages. And then you may start realizing how to use some of the functional programming concepts. Does that make sense?
Hi, just a short one. When did you come across Cinderella and Pizza? Because I've never heard of them, and quite like the names.
Yeah, they're awesome. I think Pizza is the Java superset. Sorry, I can't tell where you are. Oh, hi. So Pizza is the Java superset that's more functional, and then Cinderella, it's used in math, basically. It's more like MATLAB and stuff like that. And I just came across them when I was Googling functional programming languages. So, yeah.